So hello and welcome back to this online machine learning course. In the last video, we talked about gradient descent in great detail. We talked about linear regression in earlier videos. And today we'll be starting off with classification. So let's start off. As you can see, classification is formally defined as the process of categorizing a given data set into classes. So for example, consider these points and these points. Now my job is to segregate these data points into different classes, which I can easily do so by this or drawing a line or other cases scenarios. So we'll be looking into these algorithms. So let's for the time being assume that the problem given to me, I have a product P. It could be anything, right? It could be perhaps a gadget or a mobile phone, and I want to predict that for with a function of age whether this product would be purchased or not. So you see there are two possible cases, whether it is a yes, it would be purchased, or a no, it won't be purchased, right? And we obtain different data points for this part. Now, is this a continuous function? I hope it isn't. I hope you know by now that it is not a continuous answer. So linear regression is totally out of question. We need newer algorithms, right? So for these data points, I'm assuming that the answer is yes, this would be purchased. And for these data points, it would be no, it won't be purchased, right? So for these data points, what if we map out the probabilities that it would be purchased or not? So for these data points, the probability would be yes, it would be purchased, and the probability would be 0 that it won't be purchased. And for these data points, the probability would be 0, it will be purchased, and 1, it won't be purchased, right? Now for this data point, for example, a data point over here, we want to predict whether this of this age, will it be purchased or not? What is the probability that it would be purchased? That is what a simple question is. Let me take for this point example, yeah, a point in between. What about this point? Will it be purchased or not? Well, that is a scenario, and so we'll be dealing with classification problems, because the one with the greater probability is your correct class, right? As in this case, yes or no. So let me take this example. As you can see, the linear regression model will not appropriately fit this graph. Now we could also use something known as a thresholding function. Something like this. For a certain value x0, it would be yielding a value of 1, and for values less than x0, it would be yielding a value of 0, as you can know, as you see about this. And so we could easily say in this case that this could be a thresholding function, right? But the problem is that you cannot predict for values between these 2 points. I mean, what would you predict for these points? And what would your threshold would be? Or for example, if in actuality, the probability was something like this, and yeah, the probability for yes is more in this case, so these 2 data points would have the same effect. Not a very viable solution in real world, because in real world scenario, we experience something very different. Let me, for example, show you one thing. Now let's do an experiment. For example, I have a pan over here, and I'm placing my hand on this, and I am actually placing it over fire, and I'm noting the temperature, and at certain temperatures I'm reporting it to be hot and cold, right? So from 0 degrees Celsius I'm starting the temperature, and I'm going on till 100 degrees Celsius, and I'm doing this experiment. Now somehow at 53 degrees Celsius I note it to be hot, So for temperatures below 53, the temperature would be cold, and for temperatures above this would be hot, right? Now in practical scenario, what would the case would be? Is it something like from 0 to 53? Is it that it would be ice cold between 0 to 53 degrees Celsius, and from 53 to 100 degrees Celsius we would be experiencing something, a steamingly hot scenario setup? Well, not that. The change would be gradual. The change would be gradual, right? And so initially the probability of being cold would be around 1, near to 1, and 0 for hot. In these cases, for example, it would be 0.8 and 0.2, and at 53 we would be having a probability of 0.5 and 0.5, right? And for further hot values we would be having 1, 0 and 1 over here, and so on. I hope you get the intuition behind choosing a different function other than threshold. So we need a gradual change, like in this function. We need a gradual change because we need to predict probabilities, because this point over here is not similar, though falls in the same class, is not similar to this point, is it? So we judge with something known as the sigmoid function. The sigmoid function over here has the same graph as the one we discussed of the probabilities, and at 0.5 we are having the same probabilities, right? And here, so yeah, that's it. So we map our functions through sigmoid. Now what I mean that we map our function through sigmoid, I mean that the sigmoid gives me the probabilities. So let's, for example, take this to be the class 0 and take this to be a class 1. So the class 0 will have the probabilities of some values over here, 0.9 and 0.8, 0.9, sorry, 0.9 and 0.1. And for these values I'll be having a probability of 0.4 and 0.6. And so a sigmoid is providing me a gradual increase from between these two zeros and ones. And so yeah, that's it. So thank you for watching.